Thanks for joining us on This Week in Health IT. This is a solution showcase. My name is Bill Russell, former healthcare CIO for a 16-hospital system and the creator of This Week in Health IT, a channel dedicated to keeping health IT staff current and engaged. Today, Matt Fornito joins us. He's the head of artificial intelligence at Trace3, which is a really cool title. And we have a great conversation about what it takes to get your AI program off on the right foot, what it takes to get the right foundation set, what maturity looks like, who the first hire should be, what the budget should be, all sorts of questions like that. Great conversation. I think you'll enjoy it. Special thanks to our influence show sponsors, Sirius Healthcare and Health Lyrics, for choosing to invest in our mission to develop the next generation of health IT leaders. If you want to be a part of our mission, you can become a show sponsor as well. The first step is to send an email to partner@thisweekinhealthit.com. I ran into someone and they were asking me about my show. They are a new master's in health administration student. And we started having a conversation and I said, we've recorded about 350 of these shows. And he was shocked. He asked me who I'd spoken with. And I said, just CEOs of Providence and of Jefferson Health and CIOs from Cedars-Sinai, Mayo Clinic, Cleveland Clinic, and just all these phenomenal organizations, all this phenomenal content. And he was just dumbfounded. He's like, I don't know how I'm going to find time to listen to all these episodes. I have so much to learn. And that was such an exciting moment for me to have that conversation with somebody, to realize we have built up such a great amount of content that you can learn from and your team can learn from. And we did the COVID series. We did so many great things, talked to so many brilliant people who are actively working in healthcare, in health IT, addressing the biggest challenges that we have to face. We have all of those out on our website, obviously, and we put a search in there, makes it very easy to find things. All the stuff is curated really well. You can go out onto YouTube as well. You can actually pick out some episodes, share it with your team, have a conversation around those things. So we hope you'll take advantage of our website, take advantage of our YouTube channel as well. Just a quick note before we get to our show, we launched a new podcast, Today in Health IT. We look at one story every weekday morning and we break it down from a health IT perspective. You can subscribe wherever you listen to podcasts at Apple, Google, Spotify, Stitcher, Overcast, you name it, we're out there. You can also go to todayinhealthit.com. And now on to today's show. Today, we are joined by Matt Fornito, who is the head of artificial intelligence at Trace3. Good afternoon, Matt. Welcome to the show.
Thanks for having me, Bill. Appreciate it.
Well, I'm looking forward to this conversation, first of all, because you have the coolest title in history. We had a short phone call leading up to this, and there was so much great content that I'm looking forward to sharing it with the community. Give the community an idea of what is the title about? What do you do at Trace3?
As head of AI, a little bit of everything, really. My background comes from a PhD program in industrial organizational psychology, and somehow that segued into a lot of data science roles, had my own data science consulting firm, and then ended up joining this space on the solution provider side. And so as head of AI, what my focus really is primarily on is education and evangelization. And that occurs for our executives, our account execs, et cetera, to educate them on what AI is and what it can do, for our partners to understand what I'm seeing in the marketplace and how trends are occurring and what patterns are essentially driving AI for the future, and working with a lot of Fortune 500, Fortune 1000 customers on building out that AI journey and helping curate and build up these internal AI champions so organizations can be successful in process.
Yeah, and we're gonna delve into all of those areas. Industrial organizational psychology. Is that what you said your major was?
Yep.
That's a
grad school, at least.
You know what? That's a great major. We've talked a bunch on this show about the fact that a CIO is less about technology and more about change management and really moving an organization from point A to point B, which is a lot of industrial organizational psychology, I would imagine.
Yeah, and I think that's why I got lucky and was successful in this field, was primarily integrating the fact that everything with AI is foundationally based on the data that resonates with it, which is based on people's attitudes, behaviors, and cognitions. And the advent of all of that mixed with understanding how people operate and about transformation and change within an organization helps combine those two together.
Well, let's talk about the business problems, specifically the business problems that AI can solve. Now, you work inside of healthcare and outside of healthcare, so let's start with a discussion of outside of healthcare, because oddly enough, people inside of healthcare are looking more and more to the outside to say, what are they doing with technologies outside of healthcare and then bringing it in. So outside of healthcare, what kind of business problems are they trying to solve with AI?
Yeah, I mean, I say take a step back and look at the 30,000-foot view, right? Because a lot of people want AI and don't necessarily know what that means. And I'll say AI is the umbrella term, can be data science, machine learning, deep learning, all these different combinations of nomenclature. But AI at root is there a business problem, and is there data that can help answer that business problem? And if that's the case, then AI can help solve these things, right? Identifying patterns, clusters, et cetera. And so when we're looking at outside of AI, where is the market going and who's investing in this? Who's seeing value out of this? The primary places right now are automotive, especially with self-driving cars, and financial services. So fraud detection, likelihood of default, and those kinds of things where it can make much better decisions than humans can in regards to if a credit card purchase was fraudulent or not. But it's segueing into a variety of sectors as well. You're seeing retail use this, and when you go into a store, there may be cameras with heat map to identify where customers are going, or facial recognition to detect your sentiment and see if you're actually having a negative or positive shopping experience, and being able to have one of the retail store agents be able to interact with you if it's a negative experience. And basically right now, this advent is starting to take off more and more. So while AI started becoming much more prominent around 2011, we're seeing it put into practice a lot more today across industries.
So AI is able to take massive amounts of information, like credit card transactions and those kind of things, look for patterns. These are acceptable transactions. These are questionable transactions, and then essentially kick off a series of a workflow of some kind based on what it's seeing. Because when we think about credit card transactions, if you were to do that with people, the financial institutions wouldn't be able to hire enough people to track every credit card transaction that happens every day and look for fraudulent or acceptable transactions. So that's where the computer really steps in. And what you also described is it can, because computers now have things like computer vision and they're able to make sense of images and those kind of things, we're starting to use it in other areas where we're literally feeding it images and it's saying, that person's not happy. That person who just walked out of the store is not happy. We can tell those kinds of things based on the image.
Yep. Yeah, dead on, right? So there's three main types of use cases. There's prediction in regards to say, what is my home worth based on the number of the square footage, number of bedrooms, bathrooms, et cetera, right? And obviously there's a ton of other features that can go into that. There's classification of, is this fraudulent or not? And there's clusters, right? Who are the types of different groups that, if we go to healthcare, who are the different types of groups that doctors see, right? There might be the young people with chronic issues, and then older individuals who are just coming in for checkups.
Yeah, so how are we seeing AI applied to healthcare? There's, it's interesting. We're sort of playing recovery because one organization came in pretty loud and proud into healthcare saying, we're going to do all sorts of crazy things, making a lot of promises. And so we had to go through that and realize that there's a lot of clinical applications that are too fine at this point. We're talking about life and death, that we had to back off a little bit and say, all right, let's figure out how to use this technology and where to use this technology before we start applying it to, diagnosing patients and those kind of things at this point.
Yeah, I think of it as where's the value add, right? And I'm sure we'll get into this today, but the people that have to drive AI within an organization are the people that understand those business problems and business use cases and the cost or potential value associated with them, right? Because if you just had a data scientist come in and you tell them, go find something significant, they can do that with data. Mathematically, it's very easy to do that. But is that really going to drive, cost savings or better optimization and efficiencies, et cetera? Likely not. Within healthcare, I'm seeing the trajectory go in a couple different patterns. The insurance organizations are investing very heavily in it, have tons of data scientists, and are being able to more accurately and rapidly assess claims and approve or not. But then if you look at the hospital systems, there are some that are very progressive and some that are more laggard in regards to it. And I see it always as a crawl, walk, and run approach, right? Because organizations, let's take billing and ICD-9 and ICD-10 codes. For years and years, it had always been focused on manual. Everything has to be done manually, and that means it has to scale linearly with more labor. And then we started to get into OCR, which can hopefully detect some of those aspects within billing. But now we're getting into deep learning, which, to your point with computer vision and natural language processing, now it can read and understand the text, right? And automatically identify what was done in regards to some sort of prognosis, and then identify what the billing codes would be associated with that based on the computer vision reading the actual page and looking at entities within the page, and the natural language processing being able to understand the context of that. So the long and short answer is it's really going across the spectrum for the organizations that are moving further and further along in their AI journey. Also seeing it as things like using AI to augment doctor success. For instance, using AI software applications and models for X-rays and MRIs to detect anomalies so that doctors can be more efficient and spend more time with their patient. And also leading ultimately into personalized healthcare, right? Because at the end of the day, or at the end of this light of the tunnel, what we want to do is ultimately stop treating the disease and treat that patient holistically. And if we can do that using augmentation through AI, we should be able to reduce costs, reduce the number of treatments and other associations for a diagnosis, and get a patient in and out the door faster and happier.
Yeah, that personalization is interesting. I mean, we want to get to an N of one in healthcare because we're all a little different, and we're seeing that play out right now with the Johnson and Johnson vaccine. Generally, it's safe. It's a very safe vaccine, except for a handful of cases where it's not. And it's this kind of stuff where early on in the medical record, we had the Vioxx issue where people always ask me, it's like, is there a study that shows that the EHR, actually digitizing the record, has helped outcomes? And I just say, yeah, Vioxx. Essentially, because we had all that data scientists went in and looked at it and said, hey, look, everybody we're giving Vioxx to is having adverse reactions. And they were able to service that and change habits across all of healthcare. But when you're talking about an N of one, when you're talking about that level of customization, you're talking about 3-point-something million people just in the US alone. That's a lot of processing. That's a lot of, I don't know, that's just a lot of data that's going to be coming in. And I would think at some point, it's just going to overwhelm individuals, and we're going to need that AI, machine learning, computer vision, whatever it is, to come alongside of us and say, hey, I'm not going to diagnose, but you might want to look at this, this, and this.
Yep. No, I completely agree, because that's where I think the state of the industry, and not even just healthcare, but the state of all industries is going to be, is how can we relieve people's essentially mundane tasks, right? Or the things that we do on a daily basis that aren't quite effective, right? Ultimately, hopefully we'll get to a point where we don't even have to do emails anymore.
Oh my gosh. AI for email. Sign me up.
But yeah, I mean, I think that there's huge opportunity, especially in this space. And I think with the way that GPU computation works with parallel processing, we're getting to that point. And with the amount of data collection we have, we're getting to that point where we can get smaller and smaller clusters of people to hopefully drill into that N of one that you talked about.
Well, and we're going to get into the technology stack in a little bit, because I really do want to delve into that a little bit. But one of the things I found fascinating in our last conversation is you started talking about an AI maturity framework that you guys utilize at Trace3 as you go into organizations to really help them to think through it. Can you share the framework with us and give us an idea of how it's utilized?
Yeah, so I built up this theory and then built a model from it on 5 levels of AI maturity. And really, they are clusters to help an organization define where they're at in their AI journey and their maturity and where they want to go. So if you look at a level 1 organization, they don't have data scientists, or they might have 1 or 2 that just came out of a bachelor's degree, right? And those poor kids have no idea how messy real world data is, how disparate, how distributed, et cetera, right? And so it's kind of a wake up call, but it's for those organizations to do something a little more meaningful than just Tableau and Excel reports, right? Try to get some insights from the data, try to get something predictive, try to understand some value. When you look at the other end of the spectrum, the level 5s, it's the Facebook, the Amazon, Netflix, Tesla, Microsoft, et cetera. The companies that are doing things to completely innovate or renovate society, whether for good or bad is deterministic, but they are doing things that are so monumentally transformational that they have tons and tons, likely hundreds of data scientists. They have an executive level AI champion that is not only evangelizing this out, but really promoting it within the organization to articulate and show the value of data and these models. Because one of the biggest gaps that I see within organizations is if there's not a senior leader that is passionate about data, that is passionate about the value of what data can provide. And mind you, like, as much as I love AI can't exist without the data, right? It's, at the end of the day, it's math and science with some art mixed in, but it's that data that's really telling. And so if you have an AI champion evangelizing and promoting that out with the right team framework, with the right hardware and software applications and the right processes for that organization to be successful, then they're going to do so. Levels 2, 3, 4 basically sit at different clusters within that journey. Lower level AI champions that move up through the cycle, through the organization, more and more data science teams seeing models productionized and seeing the value, revenue, or cost savings come from those models. And those models should ultimately, and probably by level 2 actually, start paying for that team, for the infrastructure, the software applications. All the revenue that that group is making should pay for itself, because in all the analyses I've done and from what I've seen from other research teams, the value of every dollar invested in AI is conservatively 5 to 10x and up to 30x for every dollar spent.
This question is probably going to be more revealing about me than anything, which is, do I have to start on level 1 or can I start on level 3? Can I skip the process and just say, all right, that's the foundation we want to start at level 3?
Yeah, you can. And, you know, I think it takes a higher level AI champion and it takes a budget to do so. AI is fortunately or unfortunately not a cheap venture, but it's what's going to separate organizations in the next 5 to 10 years. If they're leveraging data in a meaningful way, then they're going to make a much larger impact. For those that aren't leveraging data, still doing things manually, it's going to become more problematic over time. And so like what I'm seeing currently and with a lot of customers that I'm working with involves helping build a center of excellence, right? Which is more so centralized data, centralized model repository, so that data scientists, machine learning engineers, even the analysts and whatnot, can be more successful because that data is more accessible. People are understanding what's being done. And if you have that AI champion promoting and evangelizing the wins to the rest of the organization to start leveraging that data science or analytics team, then you're going to see a lot more success. So yes, absolutely. There's plenty of organizations that I've seen that, decide to make a big investment and move forward pretty quick.
It just takes some bucks to do that, which is not always easy. Talk about the data a little bit before. I really want you to walk us through standing up an organization, but let's talk about the data first. As I think about it, I'm very familiar with healthcare data. Actually, I've worked in a lot of industries. I'm familiar with finance data and banking data, as well as manufacturing and retail data. And it's just cleaner. I mean, people a lot of times will say, why can't healthcare do this, or this? And I'll say, a transaction on Amazon is a very clean set of data. I mean, there's very little to clean up in that respect. I mean, they create all the discrete data elements and they sort of own that whole cycle. Whereas in healthcare, when somebody goes from one health system to another or one practice to another, you end up with different data entry clerks. We call them doctors and nurses, but you end up with different data entry clerks, and that's what we've turned them into. And quite frankly, it's not what they went to school for, and some of them aren't all that good at it. So you end up with notes that are just loaded with tons of great information. The problem is it's unstructured, it's hard to play with, and it's hard to really deal with. I mean, so give us an idea of what are the characteristics of data that lead to that, or at least the foundation for a good AI program.
That's a fun-loaded question.
Yeah,
okay.
Am I leading the witness? Is that what's happening here? I'm sorry about
that. Okay, we'll see if I answer this appropriately, but ask for clarity if you need it. So there's two main mechanisms, and I'm going to be a little overtly broad here. There's machine learning and deep learning. Machine learning is basically structured data. Technically, they're model frameworks that can work for other types of data, but we'll say machine learning for structured data, so SQL, Excel type files, and then deep learning for unstructured data, audio, video, text, etc. 80 to 90% of data science projects and workloads and use cases are still unstructured data right now. So in that component, it means that we need a better way for data engineering and processes to move and transmit that data and ensure its accuracy for a data scientist to leverage. And that can be done for a variety of components, especially like, let's say, front desk receptionist inputting patients' data, right? That's structured, can easily feed into a data warehouse, great. But to your point, when you get into deep learning, then you need data science talent that understands linguistics and natural language processing and or understands deep learning and computer vision. Because if you're trying to read these manual doctor's notes that are handwritten, and not only trying to read that, but being able to parse apart, understand it, and extract the relevant features or data from that, and either be able to put that into a table so that you can do machine learning on certain variables or features within that, or just leverage that as an unstructured document and do deep learning on that, is going to require a lot more lift, both from the talent side, the process side, and the infrastructure side.
We'll get back to our discussion in just a minute. Today's show is sponsored by Dell and Trace3. Dell EMC VxRail, powered by VMware vSAN, gives you a fast track to hyperconverged infrastructure, HCI, without risk, while lowering IT costs and providing an agile solution ready for future hardware, cloud, and application changes. To learn more, visit trace3.com/explore-dell-EMC-VxRail. Now, back to our discussion. All right, I'm gonna hit you up for some free consulting here. I want to set up my organization for success in AI. Where do I start? Who's my first hire? The person that I need to be the first AI person within our organization?
Yeah, I think that you have to curate that AI champion, right? Somebody that cares enough about data science and AI to help promote and see that take off.
An AI champion is my first hire. That's the category.
No, before the hiring itself. you want to have somebody that believes in this, right? And it can be as low level as like a BI manager, but if you're actually looking to get traction, productionize these models and see success with AI, then you're going to want to have somebody, and it might be a CIO, it might be a CTO, it could be a VP of or director of infrastructure. This oftentimes comes from IT. It oftentimes comes from business units themselves, right? So the chief operations officer may want better costs, better efficiencies for the organization, and knows what those use cases are. And that's why you need that AI champion, because they understand the business and they understand that there are problems that need to be solved. So from there, then the first hire you probably want to have is really contingent on what your data looks like today. So you might want a data or machine learning engineer to start getting the right data curated together in a meaningful way, because unfortunately, most data scientists are really only trained in statistics, machine learning, maybe deep learning. So they don't know how to ingest the ETLs, APIs, all those fun processes. They can't do the front end. And they can't necessarily productionize and scale those models to large scale ecosystems. So you need a data or machine learning engineer for both those pieces. And a data scientist is leveraged in the middle to build those models. And so it can go one of two ways. So if you have good data already collected, accessible, et cetera, then you probably want to hire a data scientist, ideally one that understands healthcare, because feature engineering is a key component of data science. Feature engineering means creating new variables from other variables that you already have. And those often drastically increase the accuracy of a model. So if you hire a data scientist fresh out of undergrad that doesn't know anything about healthcare, they don't know that, let's say, smoking and drinking increases the interaction of those two, increases your risk of cancer. But if somebody in healthcare does know that, then they know to create that variable and include that in a model for predicting the likelihood of someone getting cancer. So I'd say it's usually one of those two roles that really starts helping drive success.
Would it lead to a higher degree of success if we were able to get a clinician who is passionate about AI to really be the champion?
Yeah, I'm working with a few healthcare companies and hospitals and the research group. So you have a lot of doctors that know what their business problem is, and so some of them also even have, oddly enough, like engineering backgrounds, and so they're doing some of this building themselves, right? I don't like necessarily promoting or evangelizing the citizen data scientist, because if you build models without understanding the implications of what that can do to the data, then that can create very strong biases or very problematic things. And healthcare obviously being a vertical that is very prominently needs to be accurate in regards to their models for patient health and longevity. But there are a lot of frameworks that do exist, whether those are software applications or even whether it's GitHub, NVIDIA, et cetera. There are a lot of models that already exist, and there's something called transfer learning. So if you were trying to, say, detect bone breaks or build a model for bone breaks in X-ray images, those models already exist on the web. And so you could use that initial model and then ingest your own data, the transfer learning, to essentially optimize that model. And so some of these things have basically already been built. And there's also point solution software applications as well that doctors can use that like already have AI embedded in those, already have thousands of images that it was trained on. And so that's another way to start this journey.
You know, it's interesting as I hear you talking about that. There's a danger in just being clinical, in not really understanding how the models come together and how bias plays a role in it, and not really understanding the data science of it. And if you just go in the data science route and you get somebody who really understands the models and building those out, you might build great models, but you may not be connected to the business problems or the clinical problems that need to be solved. And so it's interesting to hear that and say, you know, are we trying to find a needle in the haystack here, or is this Are these people readily available? Do we have people who are data engineers who have a clinical background who can step into those roles?
Yeah, I mean, I definitely think there are. And you see people from IT segue into engineering roles or even data science roles. My perspective is the more math or the stronger the math background you have, the more adept you're going to be as a data scientist. There are plenty of software applications that can auto build models for you. So there's not a huge gap in regards to the complexity of being able to program that. But the reality is that you really do want to have people that understand the data. And more importantly, and the thing I care most about is, and I guess that goes back to my psychology background, is how do you make this actionable, right? If I can detect something with 99% accuracy, but that doesn't do anything to improve patient care, reduce costs, et cetera, then it's basically a worthless model, right? There needs to be something that can be leveraged within the outcomes of that model for it to be relevant to the organization.
Right. We hear a lot about AI ethics and bias. How do you organize in order to ensure that you're creating ethical AI models and that you're not introducing bias into these models that are going to be pretty important in terms of making decisions for how we deliver care?
Yeah, and that's where I think the statistical components comes in, right? If you look at, say, so part of a data scientist's time, actually 80 to 90% of a data scientist's time is not actually spent building the models. It's spent getting the data and the right data together. It's visualizing that data. It's exploring that data. And so if you were building models and noticed, I'll go back to my sociology degree, for instance. There was a company probably 10, 15 years ago that was trying to basically build an AI judge, right, for sentencing people. And I'll keep it brief, but essentially they fed a ton of cases into this model and built it out. And they found out that this judge bot was essentially racist because it incriminated different ethnicities at a 3x rate compared to white. And so when you look at that and then you look at it in healthcare, the data needs to be understood in a meaningful way and needs to, I don't even know where the aspect of ethics within this is critical, I think, because organizations need to be cognizant that race, gender, age, the interaction effects of drug medications, of those that may have comorbidity of different diseases, means that we have to think about these things. And that's where it gets into the N of one, because if we're not thinking about that, then we may drastically miss something or like administer some prognosis that could endanger a patient's life. So that's what I'm most concerned about within healthcare.
Is that a governance group then that we stand up who can look at the data and look at the models that we've developed to try to suss out the bias and the ethical issues?
Yeah, I think there needs to be ethics and governance, and hopefully that's done internal. It's one of those who will watch the watchers, and there's a few different AI groups that are working towards that. Credo.ai is one of them at the forefront, and really that's what I care enough about, that I want to make sure that organizations are protecting their customers or their patients. And so, yeah, I think ethics and governance around that, continuously looking at those models because they can change over time based on, patients just changing over time. It's going to be a critical element.
So we're going to talk about the technology stack, but before we get there, talk about engaging the organization. How do we introduce the organization to AI projects? What leads to a successful AI program within a healthcare organization?
I'd say it's across the board, but you want generally the business unit leader, or if it's a data science team leader, that really knows the use cases or the pain points and what the associated cost or value is with those. you also want IT involved because we're seeing more and more data sprawl, and data science teams can go rogue where they'll just upload all the data into the cloud, build their models, and IT is not being able to track or monitor any of that. So then you have to worry about HIPAA compliance. You have to worry about, is the data being deleted? Is it safe for the data to be there, et cetera? And so, it's good to have that leader involved or someone who really understands the use cases, that data science team and IT to be involved in that process. And we're talking about this more on a holistic front, right? If you're just looking to get started, it's pick one use case, have someone who understands the data and understands the math to build those models, and just start exploring that, seeing what value comes out of that, the accuracy of those models. And if they're good enough, work on scaling that into production to see what value comes of that. As long as all that goes well, then you can continue to iterate, build additional models, scale up hardware, software applications that are needed for success, et cetera.
All right. Well, we've skirted this question to this point, but let's talk about the technology stack a little bit. But what core technologies do we need to have in place to support AI?
Quite a few. If we're talking about full scale production, right? So you need fast storage, you need fast networking or switches, and you generally, if you're getting to that deep learning, that computer vision, natural language processing, et cetera, then you're going to want GPU compute. It's still light years ahead of A6 FPGAs, any of the other ones that you've likely heard of before. And so that basically means you need NVIDIA cards right now. They're really the only player in the market. Mellanox switches are great, but you also have Cisco and Juniper because you're looking at around 100 gig. And then there's a variety of storage vendors. Dell's been prominent in it. They have also been working with NVIDIA and VMware on their VX Rail to do the virtualization of all that. Beyond the infrastructure components, then you're also looking at software applications because you're likely going to want a data science platform. You're going to want a GPU orchestration tool, going to want something that can handle all of the processes from end to end, from ingestion to production. A lot of the data science platforms have that now. And if you have great people, then you also may not need a data cleaning platform, but otherwise there are some automated data cleaning platforms to help on that engineering side. That's the rough aspect, but I'd say every customer is also different.
Do organizations lean towards the cloud in this case, or do they lean in the on-prem direction, or does it really depend on what their current infrastructure strategy is?
Yeah, no, that's a great question. It's multifold, right? So if organizations are already in the cloud, it obviously makes sense for them to stay in the cloud. If they're on-prem and all of their data and they're going to buy GPUs on-prem, then that's perfect. And I often recommend it just because it allows for the data science teams to iterate, right? If you want to continue to try to build models with different parameters to increase the accuracy of those models, then doing that on-prem is great cost-wise. If you're doing that in the cloud, you're paying for the GPU compute every hour, right? But for organizations that are just starting off or more novel in the approach, if they are on-prem, they may go ahead, and we see this a lot as well, and do their training in the cloud. So building those models first with the data science team will be done in the cloud, and then they'll productionize that in the on-prem. The last piece, I guess, is really that we're seeing hybrid infrastructure where some people have some workloads in the cloud, some on-prem, and then there are also GPU colo facilities for offloading those workloads too.
GPU colo facilities, that's interesting. Are there any key players, vendors, technology players that have taken the lead with regard to AI in the technology space?
I mean, NVIDIA's definitely taken off, right? I believe they're number 2 partner, likely because the number 1 sells to all the cloud guys. And it's because that GPU compute is so prominent. There's a number of storage vendors that have been successful in this space, all the big players that you guys already know. And I'd say same for networking. When you look at data science platforms, if anyone on here wants to do research or investigate, The big players right now are Data Robot and H2O.ai, which both have auto ML platforms, which means auto machine learning, as in it can auto run thousands of models and identify the best one, right, to productionize. But beyond that, there's great data science end-to-end platforms from Converge.io to Paperspace, Dataiku, Iguazio, et cetera. And those are really what most organizations are needing right now, besides the engineering components or a center of excellence to be successful.
Well, one of the things I started to do on these interviews is throw out a goofy question at the end, which is essentially, what's the topic we haven't talked about? What's the question I didn't ask that you're kind of surprised and you think the community would benefit from a short discussion about?
I think that big takeaway is really that as many organizations are getting into this or wanting to get into this, it's a heavier lift than most people see. When I was a data scientist starting out, the number of models I built that never made it into production, which is sound with the industry, is around 80 to 90%.
Wow.
And when data scientists cost six figures, you want to ensure that you're getting value from that type of investment. And so, that's part of the reason I find these processes so important. But, really, I just look at how can we continue to iterate and demonstrate value? Because I see the healthcare space as this huge opportunity to, not only increase efficiency for patients in waiting rooms and doctors getting to have, better care for those patients, but, my significant other works in healthcare and is exhausted every day coming home. And I think, what could be done to make these doctors, nurses, RTs, front desk receptionists, how do we make their lives easier, and how do we improve patient care in the process? And my goal or hope is really that leveraging AI in meaningful ways in the future is going to help drive us there. And I just love getting to talk in this space. It's really exciting, and love getting to talk with different customers, because every single one has something unique that they're wanting to do.
One follow-up question. What leads to 80 to 90% of the models being thrown out or not used? Is it not engaging correctly early on? Is it no champion within the organization? Is it a lack of belief that AI can really do the work? Is there a cultural barrier that we need to overcome?
So yeah, great question, and you hit most of them on the head. So it's usually a small handful of things. One is that there's not processes for a data scientist model to be handed off to, let's say, a machine learning engineer to scale and productionize that model. So that tends to be one of the largest gaps, which is more so just a process and efficiency type thing. But the other prominent one that I tend to see is data scientists, and that's again why I always promote that internal AI champion, is data scientists love building and loving exploring data. But again, if there's not actionable impact or request or ask around it, then that can be detrimental. So quite a few times I've also seen that data scientists built this fantastic model for marketing, right? Let's say customer churn, and said, okay, this model, if we put this into production, we can reduce customer churn 3%, which would be 300 million in revenue per year. And then you have a CMO say, I didn't tell you to do this. Don't tell me how to run my business. And so obviously it becomes problematic if there's not synergistic alliances and things operate in silos. So really it tends to be data or people process gaps. And that's about it.
What size does an organization have to be in order to really engage with AI? Do they have to be a certain size or a certain budget or a certain sophistication in order to engage with AI?
No, I'd say not. You look at a lot of these AI unicorn startups, and they were investing. They're a lot of it built foundationally on AI, and they, with 5-10 people, are investing extremely heavily in it. Meanwhile, you can have Fortune 100 organizations that don't even have data scientists. So it's not really a people element gap. It tends to be a leadership buy-in or budgetary thing. And, that's where I think, even just that starting at level one in the AI maturity with an AI point solution, some software application that solves a unique case, whether that's, using EMR or, and to help with billing or these X-ray and MRI imaging diagnoses, and start off with something like that. If you don't have the budget or have constraints to hire a full scale data science team and engineers to productionize all that, and then see what kind of traction takes off within the organization from there.
Fantastic. Matt, thank you. Thank you for your time, and thank you for sharing your expertise with the community. It's really been a fantastic conversation, and I really appreciate your perspective on it.
No, this is great, Bill. I love it. Thank you.
What a great discussion. If you know of someone that might benefit from our channel, from these kinds of discussions, please forward them a note. Perhaps your team, your staff. I know if I were a CIO today, I would have every one of my team members listening to this show. It's conference level value every week. They can subscribe on our website, thisweekhealth.com, or they can go wherever you listen to podcasts, Apple, Google, Overcast, which is what I use, Spotify, Stitcher, you name it, we're out there. They can find us. Go ahead, subscribe today, send a note to someone, and have them subscribe as well. We want to thank our channel sponsors who are investing in our mission to develop the next generation of health IT leaders. Those are VMware, Hillrom, Starbridge Advisors, Aruba, and McAfee. Thanks for listening. That's all for now.